Welcome to Biology My Passion. I am Soumya Harikrishna. Matter in our surroundings. So we are coming to the last concept of this chapter, evaporation. Evaporation means we already learned that the liquid form can change into vapor form at a boiling point, that is 100 degrees Celsius for water. Different liquids it may vary, but they have to reach that particular temperature to change. But it's not always the same. Think of some water you are spilling on the floor. Will it remain there till it gets 100 degrees Celsius? No, after some time it will get evaporated. Or we are mopping the floor. It will dry up fast. You are keeping your wet clothes for drying. It dries fast. The water is getting evaporated from here. Or summer season. The temperature never goes to 100 degrees Celsius, but still the rivers dry up. So in this case, what is happening? The liquid gets converted into gaseous state at any temperature below their boiling point. It's not reaching 100. Below that itself, the liquid is changing into gaseous form. How is it possible? Usually, when we are taking, it's a kind of surface phenomenon. It means it happens to the surface only. But boiling is a bulk phenomenon. When we are boiling something, the temperature is being diffused equally to all parts of the liquid. And all the particles are together experiencing that boiling. But here evaporation is not like that. Evaporation happens from the surface. How it happens is, I told all the particles are in a state of movement. They are hitting each other. Hitting each other means what? They are transferring their energy. So many of them will come and hit the particles on the surface. So the surface particles will have more kinetic energy than the inside. So remember, kinetic energy is not same for all the particles. Those particles on the surface of the liquid will have more kinetic energy because they get it from the particles below them. As a result of them, they are able to overcome that force of attraction and release out as gaseous form. So from surface they get released. That is called the evaporation. For that energy level to reach, boiling point is not needed. Understood? So what are the factors affecting it? First of all, surface area. I told it's a surface phenomenon. So if more surface is available, more evaporation will happen. You are taking a glass of water, same amount you are keeping in a plate. Which will evaporate faster? The plate, because surface area is high. So this we apply in our day-to-day life. If you are keeping the clothes after washing in a pipe, it will take time to dry up. But if you spread it out on a cloth line, it faster, it dries up because from every part surface, they are exposed to surface, right? One. Second, when we go to the hotels and all, when the tea is very hot, some of us at least will pour it into the saucer and wait for it to cool down faster. Why? Because saucer has more surface area. So whenever we give more surface area, the evaporation is quicker. So we can say evaporation is directly proportional to surface area. Surface area increases, evaporation increases. Second is temperature. When temperature increases, of course evaporation is more. You know that on a dry day or a hot condition, the clothes will dry faster, or if you spill water it will dry faster. But that is not happening in a cold or a day when the temperature is less. So evaporation is directly proportional to temperature. When temperature increases, evaporation increases. Now third is humidity. Humidity means there is an amount of air, vapor in the atmospheric air. So that amount of water in the atmosphere is called the humidity. There is a particular amount it can hold. More than that it cannot go. So if there is enough water in the atmosphere already, that means the condition is humid, the water will take more time to go because there is no space. Air is not taking more water. So evaporation will be less on a humid day. In India, many southern states have more humid climate. Why? Because the air has more humidity, that means water vapor. So our perspiration or the sweat will not evaporate. So we feel so suffocated. Whereas in certain dry places, even though the temperature is very high, we don't feel that suffocation because it's sweating, it's actually getting evaporated and we are getting cooled. Okay. Now, so evaporation is inversely proportional to humidity. If humidity is high, evaporation is less. Then evaporation is directly dependent on wind speed also. That means if more wind speed is there, whatever water is coming, it will take away the water, so then more space for the water to go up. So wind speed will also increase our evaporation. So four factors are there affecting evaporation, except humidity, all will be directly proportional. Then last, evaporation causes cooling. That's what I told now. I'm sweating a lot now because here the temperature is almost 46, around 46. and I cannot switch on the AC or fan when I am shooting. That will disturb the sound. So it's very hot, but this sweat will evaporate into the vapor. So for that evaporation, it needs temperature or energy. From where that energy will be taken? It will absorb from my body itself. So once my sweat is evaporated, that part will feel very cool. Why? Sweating is an adaptation of our body to bring down our temperature also. Okay, so that's why the sweat region, if you touch, it is very cold because it is taking the heat for sweating from our body itself. So evaporation can lead to cooling also. Hope you understood all these concepts very well. Please give me your feedback. Any doubt, please post in the comment box. If you like my videos, please share with your friends, and also if you have not subscribed to my channel, please do so. Thank you for watching Biology My Passion.